Bright Tuty. Every student matters.
Hello friends, I'm back with class 8, another chapter 2 of linear equations in one variable. So we'll be studying linear equations in one variable today, and we'll be starting with the introduction of this chapter. Now we have come across with several algebraic expressions and equations which we have. Now over here, let's say 5x, 2x, 3x plus y, 2x minus 3, 2xy plus 5. These all are algebraic expressions. And we know that there are some examples of equations. Let's say 5x equals to 25, 2x minus 3 equals to 9. So equations use the equality sign which is missing in expression. So expression and equation, there is one difference between expression and equation, that is the equal to sign. Let's say 5x minus 2, this is an algebraic expression, but if I write equal to 3 and I need to find the value of x, or this is something which we have equation, we cannot say that it is an algebraic expression. We'll say that this is an equation because it has equal to sign and there is something in left hand side of that equal to sign and right hand side of that equal to sign too. So there are certain examples of equations, and we know that equality sign is something which will make it as equation to that algebraic expression. Now the highest power of the variable appearing in the expression is 1. If we check all these like 2x, 2x plus 1, 3y minus 7, 12 minus 5z. So these are the variables in the expression. The highest power of these variables is 1. Now if I am talking about variables, we know x, y, z, these all are expressions. So 2x, 3y, 2y square, 3 by 9, x, z, these all are expressions. And if I am talking about the power or the highest power or the degree, we can say what exactly it is. There is a difference between degree and power. What's that? Power, if I, let's say I have one algebraic expression 2x square plus 3x plus 1. I have this algebraic expression with me. But if I am talking about power, we have power of individual terms. So this is our first term. So x to the power 2. So this 2 is the power of this expression 2x square, or this term 2x square. Now the next is 3x, then the power is 1. And we have 1, so we can write it down x to the power 0. So here the power is 0. So the power of this term is 2, this term is 1, and this term is 0. So this is what we have as power, and I hope you know that terms are differentiated and separated by only addition and subtraction sign, not for multiplication and division. So let's say if I am writing it down, x by 2 plus 1, we have this as 2 terms. It will not be 3 terms. So x by 2, I will take it as 1 term only. Why? Because division and multiplication does not count as 2 terms. So if it's 2x, then we'll call as 1 term only. So if we have addition and subtraction in between 2 terms, then only we can say that we have these terms are differentiated with addition and subtraction. Now 2x, 2x plus 1, this is power which we have. Now if I'm talking about degree, highest power of that variable is degree. So the degree of this expression is 2. Why? Because the highest power is 2 over here. So individual term, that's power. The whole expression, highest power of that expression is the degree of that variable. Now let's say if we take few examples, x square plus 1, y plus y square, 1 plus z square plus z cube. We cannot say that this is linear expression. Why? Because for linear expression, we need degree as 1 only, not more than 1. If I'll check over here, the degree of this expression is 2. The degree of this expression is 2. The degree of this expression is 3. So we cannot say this is linear expression. This can be quadratic or cubic. We'll not talk about that. But we are for sure that it is not the linear expression. And if I'm talking about linear equation, so 2x plus 3 equals to 5. This is linear equation. But if I'll write it down, 2x square plus 3 equals to 5. This is not the linear equation. So if the degree is 1, then only we can say that's a linear equation or linear expression. Now we'll deal with such linear expressions in one variable only. So we'll not be discussing like x plus y equals to 5. So we'll not be discussing onto this. Why? Because we're discussing linear equations in one variable only, because this chapter is of linear equations in one variable. If we'll move on to senior classes, let's say 9, 10 or other classes, then we'll be going ahead with linear equations in two variables, quadratic equation, cubic equation. So as of now, I'll be dealing with equations like linear expressions in one variable only, and such equations are called linear equations in one variable. So there is certain basic things which we need to keep that in mind is an algebraic expression. An algebraic equation is an equality involving variables. It has an equality sign. The expression on the left of the equality sign is left hand side, and the expression on the right of the equality sign is right hand side. So we'll discuss what that. So this is the summary of it. Let's say if it's x plus 2 equals to 3, this is left hand side and this is right hand side. Now second point says that in an equation the values of expressions on the left hand side and right hand side are equal. So x plus 2 will be equals to 3. So the values of expression should be equal, then only we can write it on equal to signs. But this is possible, or this happens to be true only for certain values of variables. And these variables and these values are called solutions of the equation. I'll give you one example. So let's say if we have x plus 2 equals to 3. Now left hand side would be equals to right hand side if x is equal to any number. It can be any number, 1, 2, 3, 4. No, it will be some specific number or some specific digit which will be there. So if I just check it out, it should be 1. If I'll write x as 1, then only I can say that left hand side is equals to right hand side. Then this 1 is called the solution of an equation. So how do we solve it? We'll be assuming that two sides of an equation are balanced, and we'll perform the same mathematical operations on both sides of the equation so that balance is not disturbed. So let's start with any of the examples. Let's say we have 2x minus 3 equals to 7. So what do? We'll take x to one of the side and everything else to the other side. So what do? To balance both of them, we'll be adding 3 to both the sides. So we'll be adding 3 here and adding 3 here. This 3 and this 3 would cancel out. So we'll be getting 2x equals 7 plus 3, which is 10. Now the next step will be, we will be dividing both sides by 2. So it will be 2x equals to 10. So 2x upon 2 equals 10 upon 2. Now 2 and 2 get cancelled out. So we are left with x equals to 5. Now this is the only value which satisfies this equation. That means left hand side will be equals to right hand side. This is how we solve or find the solution of an equation. So the first step is, we got an algebraic equation is an equality involving variables, and we know that equals to sign, the left side of equal to sign is left hand side, the right side of equal to sign is right hand side, and to find out the solution there will be one specific value which will satisfy. So we'll be assuming that both the sides are equal, and then we'll be balancing both of them and doing same mathematical operators to both the sides. Let's say adding 3, subtracting 5, dividing 10, whatever we'll be doing on the both sides. So this is how we solve an equation. So now solving equations which have linear expressions on one side and numbers on the other side. So this is the first thing we should be discussing over here. So certain examples are, so we have the first example as, find the solution of 2x minus 3 equals to 7. So what do? We've discussed that question, but still we'll write it this way. So we are in 2x minus 3 equals to 7. We'll be adding 3 to both the sides. Then 3 get cancelled out. We are left with 2x. 7 plus 3 is 10. And then we'll be dividing it by 2 to both the sides, and we'll be getting x as 5. So this is the value or the solution of 2x minus 3 equals to 7. This is one way which you can find the solution. There is another way as well. What's that? If we have 2x minus 3 equals to 7, So over here 2x minus 3 equals to 7. What do? We'll keep the term, we'll keep that variable, or we'll keep that expression which have x in it to one side, and we'll shift everything to the other side. So what do? We'll keep 2x here and we'll be shifting it to the other side. So when we'll be shifting, there will be minus will becomes plus. We have discussed these questions in class 7 and class 6 as well. So we can use any of the methods. So ultimately what are we doing? We are doing the same thing, but we are not showing it off, but we are balancing both the things only. So we'll be getting 2x equals 10. Since we are multiplying over here, so over here there will be divide and we'll be getting 5. So you can use any of it and you can come up with the final solution. Now let's move on to the second example. Solve 2y plus 9 equals 4. So either you can subtract 9 from both the sides and then move on, or we can do the same way, which is this. 4 take away 9 is minus 5. So y is equals to minus 5 by 2. So this is the solution of 2y plus 9 equals 4. Let's move on to another example. Again, we have x by 3 to one side and we'll take all the other numbers to the right hand side. So what do? We will be writing it this way. We're keeping x by 3 as it is. Minus 3 by 2. We hear it's plus. Moving on to the right hand side, that will be minus 5 by 2. Now x by 3 equals, taking LCM, we'll be getting minus 3 minus 5. So x by 3 equals minus 8 by 2. X by 3 equals minus 4. Now over here it's dividing by 3, so we'll be multiplying it to the other side if we'll take it to the other side. So x will be minus 12. So this is the solution of the equation which we have over here. So this is how we solve the equations. Let's move on to another example which we have. Solve 15 by 4 minus 7x equals to 9. So what we'll be doing is we'll be keeping x term to the left hand side and we'll shift everything to the right hand side. So we'll be getting 9 minus 15 by 4. Taking LCM, we'll be getting 36 minus 15, which is 15 plus 6, which is 21 over 4. Now we have x over here, 21 by 4 into 1 upon minus 7. So we'll be dividing here like this, cancel this out, and this will be 3. So we'll be getting 3 over minus 4. So x will be minus 3 by 4, which is the solution of this equation.